Introducing ratio. Learning goal. I can use a ratio to determine two numbers. I can also describe any ratio situation using many ratios and fractions. Emile has 10 quarters, 4 dimes, and 6 nickels. Write a ratio for each comparison below. Okay, so the first one says to compare the number of dimes to the number of nickels. If we look here, we can see we've got 4 dimes and 6 nickels. So to compare the number of dimes to the number of nickels as a ratio, we say that there are 4 dimes, then we put a colon, and 6 nickels. So the ratio of dimes to nickels is 4 to 6. Now for part B, it says compare the number of nickels to the number of dimes. In that case, we're just reversing the two numbers. There are 6 nickels to every 4 dimes. Part C says to compare the number of quarters to the number of dimes. So we look at our number of quarters, and we've got 5 on the top and 5 on the bottom. So we have a total of 10 quarters. And the number of dimes hasn't changed, so that is still 4. So we have a ratio of 10 to 4. Now we compare the number of dimes to the total number of coins. Since we've got 10 quarters, 4 dimes, and 6 nickels, that's 20 coins in total. And we're told to compare the number of dimes to the number of coins. So the number of dimes is going to be first, and we've got 4 to 20. So a ratio of 4 to 20. Part E says compare the number of nickels to the total number of coins. So it's not a big stretch now to see that we've got 6 nickels to a total of 20 coins. So we have a ratio of 6 to 20. In question 2, this time we're asked to write a ratio again, but this time we're comparing the value of the coins rather than just the number of coins. So the value of the dimes is 40 cents because it's 4 times 10, and to the value of nickels, and 6 nickels is 6 times 5, which is 30. So we've got a ratio of 40 to 30. Part B says compare the value of the nickels to the value of the dimes, and we're just going to reverse those numbers. So 30 to 40. Now we compare the value of the quarters to the value of the dimes. The value of the quarters, I can see that if I put 4 quarters together, that's $1, $2, and 2 more quarters makes 50 cents. 250 cents to the value of the dimes, which is 40. Now we compare the value of the dimes to the value of all the coins together. So the value of the dimes is 40. And the value of all the coins together, we've got $2.50 plus 40 cents is $2.90. So plus another 30 is 320 cents. So we've got a ratio of 40 to 320. Part E says compare the value of the nickels to the value of the coins. The value of the nickels is 30, and the value of the coins we said was 320. The ratios in question 1 are different from the ratios in question 2. Why does that make sense? Well, if we go back and look at the two ratios, let's take the dimes to the number of nickels, which is 4 to 6, and compare that to the value, which was 40 to 30. Now, because each of the nickels was worth less than each of the dimes, here we had the 4 being multiplied by 10 and the 6 being multiplied by 5. So if you're multiplying both sides of the ratio by different values, it's going to change the ratio. So because the number of coins in each category stayed the same, but the amount that each of them was multiplied by was different, that gave us a different ratio. We're working with the same set of coins again, and this time we're asked to compare the number of nickels to the number of coins. But this time, rather than using a ratio, we're going to use a fraction. So a fraction that represents the number of nickels to the number of coins in total. There are 6 nickels, and there are 20 coins in total. So previously we said the ratio was 6 to 20. When we turn it into a fraction, it just becomes 6 divided by 20. To compare the number of dimes to the number of coins as a fraction, we use the same approach. 4 out of a total of 20 coins. So that's the same as saying 4 to 20, or 4 colon 20. Question 5. Write a fraction for each comparison below. Compare the value of the nickels to the value of the coins. Well, we remember that the value of the nickels is 6 times 5, which is 30, and the value of all the coins was 320. And the value of the dimes to the value of the coins was 40 out of 320. So again, remember those ratios were 30 colon 20 and 40 colon 20. So two different ways of representing the same information, fraction and a ratio, but effectively they mean the same thing. If we investigate a little more what the fraction means, we've got 30 cents out of 320. So 30 cents in nickels came out of the total of 320 cents. Question 6 says to create a coin collection, use quarters, dimes, and nickels. The ratio of 3 to 8 should describe your coins in some way. So for my example, I'm going to say, okay, well, I'm going to let the 3 be the number of quarters. So I've got 3 25-cent pieces, and the 8 is going to be the total number. So to get total number, I'm going to say I've got 2 dimes and 3 nickels. In doing so now, I've got 3 25 pieces out of a total of 8 coins. That gives me a ratio of 3 to 8, or 3 out of 8 coins are quarters. So that answers part B of the question as well. Part C says we're supposed to write a ratio and a fraction for each comparison. Compare the number of nickels to the number of coins. So the number of nickels in my case is 3 compared to the total number of coins, which is 8. The next part says to compare the number of dimes to the number of coins, and that is 2 out of 8. And compare the number of quarters to the number of coins. Well, that's what we started with, which was 3 out of 8. Remember, we could have written those ratios as 3 colon 8, 2 colon 8, and again 3 colon 8. Lesson summary. Any ratio can be described by many ratios. Some are part-to-part ratios, and some are part-to-whole ratios. For example, in this picture we've got 1 student in every 5 that rides a bike to school. So we see we've got 1 student with a bike, but there are 5 students in total. So the ratio is 1 to 5. The part-to-part ratio is 1 to 4 when you compare the number of bike riders to non-bike riders. So again, we have the 1 bike rider, and we have 4 non-bike riders. The part-to-part ratio 4 to 1 reverses that and says we're comparing the number of non-bike riders to bike riders. So when you're writing out a ratio, you see we've got something that says non-bike riders to bike riders. That's the ratio that we're going to create. So the non-bike riders, the count of those becomes the first number. And the part that comes after the 2, in this case the bike riders, is the second number, which in this case is 1. The part-to-whole ratio, 1 to 5, compares the bike riders to all the students. So again, there's 1 bike rider, so that's the part that comes before the 2, and then we've got compared to all the students, so that's the second number in the ratio. The part-to-whole ratio, 4 to 5, compares the non-bike riders to all the students. You can also describe a ratio situation using a fraction. For example, in a group of 5 students, 2 are walking and 3 are running. The ratio of students walking to the whole group is 2 to 5. That means a fraction of 2 out of 5 of the group is walking. The ratio of students running to the whole group is 3 to 5. That means 3 out of 5 of the group is running. It's important to be clear about what the terms of a ratio represent. So the first number always refers to the first part of the ratio, and the second number that follows the colon refers to the second part of the ratio. For situations involving coins, The ratios that compare the number of coins are different from the ratios that compare the values of the coins. The ratio of the number of dimes to quarters is 4 to 3, but the ratio of the values of dimes to quarters is 40 to 75, which is significantly different. Even if you reduce this ratio by dividing each number by 5, you get a ratio of 8 to 15, so still different from the 4 to 3 ratio. Key terms. Part-to-part ratio. It's a ratio that represents a relationship between one part of a whole number and another part of the same whole number. For example, if there are 5 adults and 3 children in a group of 8, the part-to-part ratio of adults to children is 5 to 3, or 5:3. A part-to-whole ratio is a ratio that represents a relationship between one part of a whole to the whole. For example, if there are 5 adults and 3 children in a group of 8, the part-to-whole ratio of children to the group is 3 to 8, or 3:8. Ratio. A ratio is a comparison of 2 or more quantities. For example, if there are 5 adults and 3 children in a group of 8, the ratio of adults to children is 5 to 3, or 5:3. Term. A term is each part of a ratio. For example, in the ratio 5 to 3, 5 and 3 are the terms. Your turn.